are given two polynomials and we are asked to add them. You can only combine like terms. You can only combine the x's that have the same exponent. So 5x squared can be added with 7x squared. That gives you 12x squared. Since we are adding, we do not add the exponents. 1x plus 1x is 2x. You keep the base the same for that, and you do the same thing for these problems. 5x squared plus 7x squared, you just add the coefficients and keep the base the same. Then you can combine the negative 8x with negative 9x. Negative 8x plus negative 9x is negative 17x. And then negative 6 plus negative 3 is negative 9. This problem asks us to subtract two polynomials. You have to use the same idea that you do in adding. You can only combine things that have the same terms. So that means only the terms with the x squared can be subtracted, only the terms with the x's can be subtracted, and then the constants are subtracted from each other. The easiest thing to do to keep you from making mistakes is to change the sign in the middle from subtraction to addition. Since you are making that sign opposite, you need to make every sign to the right of that opposite. Therefore, what you have is 3x squared plus 5x minus 9 plus negative 6x squared minus 5x plus 11. From there, you combine like terms. You get negative 3x squared plus negative 6x squared, positive 3x squared plus negative 6x squared will equal negative 3x squared. Then you have 5x plus negative 5x. That goes to 0. Then you've got negative 9 plus 11, which is equal to a positive 2. When you change your sign to addition in the middle and change every sign to the right of that, you give yourself less chance of making a mistake. In this problem, we are asked to multiply. We have one term multiplied by an entire polynomial. That polynomial has 3 terms. Since it is one term multiplied by the entire polynomial, we use our distributive property and we multiply each term in the polynomial by 7x squared. When you do 7x squared times 9x y cubed, you will first multiply the coefficients, so 7 times 9 is 63. Then you have x squared and x. Those two things have the same base. When you multiply things with the same base, you add the exponents. So you get x to the third. And then we still have y to the third. We have nothing else with that same base, so we just rewrite it in our answer. Then we've got to distribute 7x squared to the second term. We again multiply the coefficients first, so 7 times negative 8 is negative 56. Then we have x squared. There is nothing in that second term of the polynomial that has the same base, so we keep x squared in our answer. Then we also keep z to the fourth and y in our answer. It's all being multiplied, so it needs to be in our final answer. Then we multiply 7x squared by the last term of the polynomial. We multiply the coefficients first. 7 times 4 is 28. And then we've got x squared and y to the third. None of those have the same base, so there's nothing we need to combine in the exponents. We just get 28x squared y cubed. This problem right here is one of my favorites. You have x minus 4 squared. The key to this problem is to realize that x minus 4 is considered the term. Yes, it's a binomial. So what this problem means is that that entire binomial is squared. Squaring means to multiply something by itself. Well, the term that's being squared is x minus 4. So we have to rewrite this to be x minus 4 times x minus 4. Then you will use your double distributive property. Your first terms of your binomials multiplied together plus your outer term, then plus your inner two terms multiplied together plus your two last terms multiplied together. So we get x times x is x squared, x times negative 4 is negative 4x, and then negative 4 times x is negative 4x, and then negative 4 times negative 4 is a positive 16. You can combine your like terms to simplify this expression, and you get x squared minus 8x plus 16. We are going to use the same idea that we did in the last problem. We have two binomials multiplied together, so we will use double distribution. Some of you prefer to use the FOIL method, and that is fine. You will come up with the same answer. So we need to multiply each term in the first binomial by each term in the second binomial. So we get x times x, which is x squared, and then x times 7, which is 7x. Then we do negative 6 times x, which is a negative 6x, and then we do negative 6 times a positive 7, which is a negative 42. So when you add those terms that you just got from double distributing, you combine like terms so that we can simplify our expression, and we end up with x squared plus x minus 42. Remember, 7x minus In this problem, we have a binomial multiplied by a polynomial with three terms. We have to distribute both terms in the binomial to all three terms in the polynomial. So we are going to double distribute, but we are going to be distributing those first two terms to three different terms. So it's just like an extra step. So we do x times x squared, which is x to the third, x times negative 4x, which is negative 4x squared, x times 6, which is 6x, and then we do negative 2 times everything in the polynomial. Negative 2 times x squared is a negative 2x squared. Negative 2 times negative 4x is a positive 8x. Negative 2 times 6 is a negative 12. We now have our expression after we distributed both terms to the polynomial. We can now clean this up and simplify our expression by combining like terms. You must combine the terms that have the same base. All of these have the same base, but they may not have the same exponent. An x cubed term cannot be added or subtracted with an x squared term. So what we can combine is our negative 4x squared and our negative 2x squared. And then we can combine 6x and 8x. Your final answer comes out to be x cubed minus 6x squared plus 14x minus 12. This question asks us to find the perimeter of the deck shown below. We are given a diagram, which is a trapezoid, and we are given the length of all four sides. Instead of actual measures, we are given expressions for all four sides. But we know that perimeter just means to add them all up. So what you're doing is you're adding four different binomials. So create your expression, which will be x plus 3 plus 2x plus 4 plus x plus 3 plus 10. And then you combine your like terms to get 4x plus 20. In this question, we are asked to find the area of two different figures. Part A is a rectangle, and we know that the area of a rectangle is length times width. Our length of this problem is a binomial. It's 4x plus 2. And the width of this rectangle is another binomial, which is x plus 2. So we are multiplying two binomials to get the area of this rectangle. We have previously done multiplying binomials, so you need to double distribute or use your FOIL method. Don't forget to combine like terms so that you have a simplified expression. Your final answer should be 4x squared plus 10x plus 4. And then for the shape in part B, you were given a triangle. The area of a triangle is 1/2 times my base, or times your base, times your height. In this problem, the base is 2x plus 6 and the height is x plus 3. The easiest way to do this is to multiply out your binomials first, then distribute your 1/2. So do base times height and double distribute or use FOIL. Simplify that and you get 2x squared plus 12x plus 18. Then multiply all of that by 1/2. So you will distribute 1/2 to each of the coefficients of those three terms to get your final answer to be x squared plus 6x plus 9. Because 1/2 times 2 is 1, so that leaves me with 1x squared. 1/2 times 12 is 6, so I'm left with 6x, and then 1/2 times 18 is 9. This question asks us to find the area of the white space. I know in your picture it's hard to figure out which is the white space and which is the shaded space. The small rectangle is considered the shaded space, and we are trying to find everything that is around that. So in order to find that portion that is around the grade shape, we need to find the area of the entire rectangle and then subtract it from the area of the little piece. What that leaves us with is the space around it. So in order to find the area of the big rectangle, you do the length, which is x plus 3, times the width, which is 2x. You are going to distribute 2x to both terms, and you are left with the area of the big rectangle is 2x squared plus 3x. And then to find the area of the small rectangle, you again use length times width. Our length is x plus 2 and our width is x. So the area of the small rectangle is x squared plus 2x. We then need to do the area of the big minus the area of the small. So we have two binomials subtracted. Remember back in problem 2, when we subtracted polynomials, we changed the sign in the middle to be addition and change every sign after that. So what we will have is 2x squared plus a negative 1x squared. That leaves us with positive x squared. And then we have 3x plus a negative 2x, which is a positive 1x. So the area of the white space is x squared plus x. This problem asks us to find the volume of the rectangular prism. Some of you may remember that volume is length times width times height, but just in case you don't remember, the volume formula that is given on the EOCT is big B times height. Remember, big B is the area of our base. The base of a rectangular prism is a rectangle, so big B is length times width. So we want to start by finding the area of the base. The length is x plus 6, the width is x plus 1. So you've got two binomials multiplied together. So you will double distribute or FOIL, whichever method you prefer, and then simplify that to make your life a little easier. You get the volume of the base to be x squared plus 7x plus 6. Then we need to take that and multiply it by our height, which is x plus 3. This is a little bit longer of a step because you've got 3 terms multiplied by 2 terms. But you're still going to use the same idea of distributing every term to every term in the other polynomial. You will then simplify your expression by combining like terms. You should get x cubed plus 10x squared plus 27x plus 18. This problem is the lengthy problem This asks us to evaluate I to the 12th. There are only 4 properties for imaginary numbers. I to the first, which just equals I to the second, which is equal to -1, I to the third, which is equal to I times -1, so it is -I, and I to the fourth, which is equal to I squared times I squared, which is 1. There are 4 properties that you have to memorize, and they will keep looping back around to either be I, -I, 1, or -1. So what you do is you take your exponent and you divide it by 4, since there are 4 properties. All that you are looking for after you divide is the remainder. 12 divided by 4 is 3, so it has no remainder. So if you look at your iClock, you are going to end up at I to the 4th, because that has no remainder. So I to the 4th is equal to 1. Therefore, I to the 12th is equal to 1. This is another problem where we are going to use our iClock. There are 4 properties of I, so since there are 4, we divide our exponent by 4. All we are looking at is the remainder. The remainder is 0.75. 0.75 is equivalent to 3 over 4. So we are going to look at the third property out of the 4 properties, and that gives us I to the third. That's the third property in our list. I to the third is equal to -I. Therefore, I to the 27th is equal to -I, or equivalent to -I. We have I to the 121st power. You are going to divide that exponent by 4. When you divide that, you look at the remainder. The remainder is 0.25, which is equivalent to 1/4. So we are going to look at the first property out of the 4 for our imaginary numbers. The first property is I. So I to the 121st power is the same as I. We have 2 complex numbers subtracted. Remember, complex numbers have a real part and an imaginary part. You treat complex numbers just like you do a variable. So we are going to combine the real parts and we're going to combine the imaginary parts so that I is essentially like an x. Since they are being subtracted, we will change that sign to addition and make every sign to the right opposite. So we keep the first complex number as 2 plus 5i, then we change the subtraction to be adding, and we'll change the second complex number to be 4 plus 12i. You will combine your real parts, so 2 plus 4 gives me 6, and then you're going to combine your imaginary parts. 5i plus 12i is 17i. Always write your answer in standard form, which is a plus bi, or the real part plus the imaginary part. This problem is 2 complex numbers multiplied together, so we will double distribute or FOIL just like we do if this was 2 binomials with variables. What you get when you do this is you get 4 times 6, which is 24, plus 4 times 5i, which is 20i, plus negative 5i times 6, which is negative 30i, plus negative 5i times 5i, which is a negative 25i squared. You will combine your like terms, so you get 24 minus, that should say 10i, minus 25 times negative 1. Remember, you can never have an exponent in the standard form of a complex number, so we change I squared to be negative 1. So we get 24 minus 5i, remember that should say 10i, plus 25, because negative 25 times negative 1 is a positive 25. So then 24 plus 25 is 49. So the answer for this one should be 49 minus 10i. This problem is dividing 2 complex numbers. When you divide by a complex number, you need to multiply the numerator and the denominator by the conjugate of the denominator. The conjugate of a complex number is just changing the sign of the imaginary part. So you keep the real part the same, you keep the imaginary part the same, you just change the sign of the imaginary. So we will multiply the numerator by 1 minus 3i, and we will multiply the denominator by 1 minus 3i. Now remember, anything divided by itself is essentially 1. So we can multiply this by the conjugate because it's just multiplying by 1. So what this will do for us is simplify our problem. So we are going to double distribute or FOIL on the top. We will double distribute and FOIL on the bottom. Don't forget that you can never have an exponent with the I, so you will always change I squared to be negative 1. What you should end up with on the bottom is a constant. Anytime you divide by complex numbers, you should end up with a constant on the bottom. So on the top, when we double distribute, simplify, and then when we change I squared to be negative 1, we get 17 minus 16i. Then on the bottom, when you double distribute and multiply out, your I terms cancel out, or they go to 0, and you're left with 1 minus 9i squared. We change I squared to be negative 1, so we get 1 minus 9 times negative 1. A negative 9 times a negative 1 becomes a positive 9, so we add that to 1 to get 10 for our denominator. This problem wants us to simplify 7i squared minus 3i to the 6th power. Well, we know we need to write our answer in standard form for a complex number, which is a real part plus an imaginary part, and there is no exponent with the I. So we are going to change I squared, and we are going to change I to the 6th. I squared is equal to negative 1. That is one of our 4 properties of imaginary numbers. So we get 7 times negative 1. So we know that first term comes out to be negative 7. Then we have minus 3i to the 6th. If you look at the top right, what I did was I decided to evaluate what I to the 6th was. I did it to the side so you could see what I did. You divide the exponent by 4, and you are looking at the remainder. The remainder is 0.5, which is equivalent to 2 over 4. So you are going to the second property, or the second spot on your I clock, which is I squared. I squared is equal to negative 1, therefore I to the 6th is also equivalent to negative 1. So we know that our first term came out to be negative 7, so we are going to subtract 3 times negative 1 from that because we got I to the 6th to be negative 1. A negative 3 times a negative 1 becomes a positive 3. So negative 7 plus 3 is negative 4. This problem wants us to rewrite an exponential form. The key to this is remembering that the square root of x is actually equal to x to the 1 over 2. So squaring essentially means that there's 2 outside of the square root, and there is a 1 in the exponent. So what we do is we take the base and we raise it to the exponent over the index, which is the number out front of the square root. So we get x to the 9 over 4.
To rewrite in radical form, we know that it's exponent over index. Our index is 3, so it's the cubed root of 4x squared in parentheses squared. You can actually simplify this more than what's in the picture. It could be the cubed root. 4 squared is 16 to the x to the 4th. So cube root 16x to the 4th power. is out of the entire population of 36, I have 15 prime numbers I could get when I roll two. For this one, it says simplify each expression completely. You can kind of do this one two different ways. You can take everything that's under the radical and put it in rational exponent form. So you have 256 to the 1/4, a to the, remember it's exponent over index, 16 over 4, b to the 20 over 4, and c to the 13 over 4. You also can list out 16 A's, 20 B's, 13 C's, and then circle your groups of 4. But we'll go with this one that's written on here. 256 to the 1/4, or the fourth root of 256 is 4. So that all comes out of our radical. There's nothing left over. Then we say 4 goes into 16 4 times. So I can pull out 4 A's and nothing's left. There's no remainders. For B, we have 4 goes into 25 times. Again, there's no remainder, so my 5 B's come outside. And then for C, I have 4 goes into 13 3 times. But there is one remainder. 4 times 3 gives me 12, and there's a difference of 1 between 12 and 13. So 1C has to stay inside. So it's 4, a to the 4th, b to the 5th, c cubed, 4th root c. For this one, we have the cube root of 125 x cubed all over 8. So you can actually separate our cubed roots. We have cube root of 125 x cubed divided by the cube root of 8. And then from here, we can take it and put a rational exponent form. So 125 to the 1/3 times x to the 3/3. Remember, it's exponent over index. And then 8 to the 1/3. So the cube root of 125 is 5. X is 3, goes into 3 one time. There's nothing left over. And then the cube root of 8 is 2. So it's 5x divided by 2.
This problem can be really tricky if you do it out by hand. But the good thing about this is if you get this on the EOCT, always try to save yourself time for harder and more complicated problems. This problem has absolutely no variables. Therefore, if you are using the Multiview calculator or the TI-36 Pro calculator, you can plug this into your calculator the exact same way you see it on here. You are going to
For this one, it says simplify each expression completely. So we have 2 fifth root 8 x to the fourth y squared times fifth root 8 x squared y cubed. Again, a lot of these you can kind of do different ways. You could actually put everything that's under the fifth radical under one radical just by multiplying it all, or you could do what's in this worked out solution. You can change everything into rational exponent form, so you have 2 on the outside times 8 to the 1/5, x to the 4/5, y to the 2/5. Gotta remember it's exponent over index. Then times 8 to the 1/5, x to the 2/5, y to the 3/5. We have our 8 to the 2/5 times 2. You can put that in your calculator and you get 4. We can multiply our x to the 4/5 and x to the 2/5, and we get 7 over 5. And then we have y to the 2/5 times y to the 3/5, and we get 5 over 5. Remember, when you're multiplying by same base, you add your exponents. The nice thing about these is they all have common denominators, so you just add the numerators. And then 5 goes into 7 once, so one of my x's can come outside, but there's a difference of 2 that has to stay inside the radical. And then for my y, 5 goes into 5 once, so 1y can come outside. So you have 4xy fifth root x squared. For this one, we have the fourth root of 16, x to the 2/5. So we can take our fourth root and make it 1/4 as an exponent. It's the same thing. So we have 16 times x to the 2/5 to the 1/4. And then we can distribute that exponent. So we have 16 to the 1/4. And then if it's a power raised to a power, like in this case, you multiply those exponents. We have 2/5 times 1/4 gives us 2/20. The fourth root of 16 is 2, and then x to the 2/20, 2 over 20 reduces to 1 over 10, so it's 2x to the 1/10. Okay, so for this one we have 8 times x cubed times y to the 6, all raised to the 2/3. So we can just distribute that 2/3, so it's 8 to the 2/3, and then for x and y, these are power raised to power, so we multiply exponents. So we get x to the 6/3, y to the 12/3. Remember, again, we're multiplying those exponents, not adding this time. So 8 to the 2/3 gives us 4, and then we can simplify our fractions and get x squared, and then y to the 4th. For this one, it's much easier to put them all in the same form, so we can put them in rational exponent form. So the cube root of x, we can just write as x to the 1/3, and then from here, it's just easy to do. Since it's multiplying by the same base, you add the exponents, so we're going to add 1/3 and 1/2, and that gives us 5/6. And again, you need to make sure that when you're adding fractions, you get common denominators, and the common denominator here would be 6. So when we get common denominators, we get x to the 5/6 and x to the 4/6. When we subtract, remember when dividing by the same base, you subtract exponents and we get x to the 1/6. This one looks complicated, but it's really not. You can multiply your coefficients first, so 2 times 4 times 8 gives you 64. And then remember, when you're multiplying by the same base, all you do is add your exponents. So you get 1/3, 1/2, and 2/3. Your common denominator here would be 6 to add them together. And so when you add these all together and reduce your fraction, you get x to the 3/2. So it's 64 x to the 3/2.
This problem wants you to find the volume for 3 different shapes. The first shape is a cone, the second shape is a pyramid. On your EOCT, the formulas that you will be given for a cone and a pyramid are 1/3 big B times height. We have to know that big B means the area of the base. That is not given to you. So for the first shape, our base is a circle. So the area of the base is pi r squared. When we put in our radius for the cone, we get 36 pi to be big B, or the area of our base. We will then do 1/3 times 36 pi times our height, which is 14. When you plug this into the calculator, you may end up with an answer that has pi in it. To change it to be a decimal, you press the button above enter. And you should get 527.79 centimeters cubed. And then part B, we have a rectangular pyramid. So we find the area of the base by doing length times width. So big B, or the area of our base, comes out to be 56. So then we can use the formula that we're given, which is 1/3 times big B, which is 56, times our height, which is 6. You will get 112 inches cubed. Volume is always measured in units cubed. Part C, or our third picture, is a cylinder. The volume for a cylinder is big B times height. You do not multiply by 1/3 for a cylinder. So big B is pi r squared because our base is a circle. So for this problem, our big B equals 16 pi. So we will then multiply 16 pi by our height, which is 12. If you were to turn the cylinder and stand it up, the height would be 12. When you get your answer, you can always change it to a decimal by pressing the button above enter, and you should get 603.19 centimeters cubed.